Does anybody remember what a monomial is? It was in 7-1. It was the last section we did.
Yeah, I remember Miss Nichols talking about it.
Yeah, it was Miss Nichols did it, those notes with y'all when I was gone. Jackson?
Is that the one? I don't know. Where it's like a variable,
Uh-huh.
but it's like a number.
Yes, you're right.
It's by itself, or it can be in the denominator.
Okay, it's a number, a variable, or it's a product of numbers and variables. So Jackson started to say this, but there's a few things, like specific things that we can't have with monomials. One of them, Jack. Yes, no addition or subtraction in a monomial. One other thing. 7? Right, no variables in the denominator. So one thing that we really didn't talk too much about before, but we can talk about now, is you also can't have negative exponents. Okay, because think about, to get rid of a negative exponent, where do you move it? The denominator, and then you would have a variable in the denominator. Okay, so we didn't talk about that before because at that time you didn't really know about negative exponents, but now we can. But no variables in the denominator, no adding or subtracting, no negative exponents. Okay? But all of this has to do with monomials. First we have a polynomial. So a polynomial is either one single monomial or it's a sum of several different monomials. Okay, either one of those two things. So then we have two other terms right here. We have binomial and trinomial. These two terms right here are types of polynomials. Okay, so that's like, it's like these two are more specific types of polynomials. A binomial is a polynomial that's made up of two monomials, so it's two different monomials being added together. And then a trinomial is made up of three monomials, all being added together. It's almost like these two are more specific names for this one. It's like saying you're a student, but a more specific name for you is you're an 8th grade student. Okay, so a polynomial is monomials being added together. A binomial is specifically 2. A trinomial is specifically 3. No, after 3, they don't have specific names. After 3, you just call them polynomials. They don't have names. So another example of a binomial can be something like this. Okay, so the reason that this is a binomial is because it's two monomials being added together. So I know it says sum right here, but it doesn't have to be a sum. It can be a difference too. Like you can have something like this. Okay, 2 minus x. Because 2 is a monomial, and so is x. Do y'all know why they just say sum though? You could also write this like this. So, it's because you could write it as a sum. That's why they say it that way. But either way, it's still 2 monomials. Okay, so 3 monomials, that's a trinomial. That's something like this. Okay, so this is a trinomial because it's 3 terms. 1, 2, 3. Okay, any questions so far? So we have degree of a monomial. So degree of a monomial, this is the sum of the exponents of all its variables. Okay, notice it says variables, the exponents that go with the variables. So if you look right here, we have 2xy. The degree of this is 2. So the reason why is think about what exponent goes with the x. And what exponent goes with the y. So if I add the exponents together, I get 2. So think about one like this. 3x squared y to the 5th. Yeah, the degree is 7. We're going to use it in just a second with the standard form stuff. It just kind of is going to help us all be able to write our answers in the same way. Yeah, you only look at the exponents when you do this. So what is the degree of this one?
No, 5.
5, yeah. So, because there's exponent of 1, exponent of 1, exponent of 3. So you have a degree of 5. It's 1, 1, 3. No, we're not using, don't look at the constant, or the coefficient. Don't look at that at all. Only look at the exponents. What about this one? Remember up here I underlined variables? It's the exponents with the variables.
So that's
0. Okay, it says it right here. Constants have a degree of 0. Okay, so degree of a polynomial, this can get a little confusing. You're already confused?
They're not complicated, but like just weird.
Do you understand the degree?
I mean,
I get it, like splitting it up, but if you like give me a whole worksheet and you're like, oh, what the
No, you'll get the hang of it. You'll get the hang of it. We're about to practice them. Okay. We're about to put it all together. You'll get it. Okay, so when it says degree of a polynomial, it says the greatest degree of any term in the polynomial. Okay, so what you want to do is break apart this polynomial into monomials. First look at 7rx. Do we know what the degree of this is? I'm sorry, 5rx, my bad. So the degree of this is 2. And then we have 7tuw. What is the degree of that? 3. Okay, so the degree of the whole polynomial is the greatest degree, which is 3.
So the first one is better?
It's the greatest one. So, look at this. Okay, so what you want to do is look at each part individually. First, what is this? A monomial, binomial, or trinomial? Trinomial. I need to break it apart and look at all 3 parts. So, first I have 2x squared y. What is the degree? 3. Because I add 2 plus 1 to get 3. Okay, what's the degree of this one? And the degree of the last one? Okay, so now I can say the degree of the polynomial is the highest one. So that is 4. Okay, the problem with it that a lot of people want to do is they want to add all of them together. And so the degree of the polynomial is 9. You know, I think the reason that we go with the highest one is which we'll get into this fourth 9 weeks. But the highest exponent, when you graph things, it determines what the shape is going to be. So, like, if it's a degree of 1, it's going to be a straight line. And, like, fourth 9 weeks, we're going to get into degrees of 2. It's going to be like a U. And then a degree of 3 will be like an S, like sideways. And then 4 is like a W. So, I think that's why we pay attention to what the highest degree is. That's my guess, at least. Yeah, I understand. Yeah, I understand what you mean, but I think that's why they do it. Okay, so this is why we use the degrees, for right now, at least, is so we can write it in standard form. So we want to write things in standard form. To me, the main reason is so it's easier to check your answers. So it's easier to know if both of us got the same answer. Because, like, think about it, if it's 5 terms long, and we all wrote it in different orders, it gets a little crazy. So when you're writing it in standard form, you write the terms in order from greatest to least degree. So start with the biggest degree and rearrange it until you get to the smallest. For example, right here, if you look at this, first they wrote 4x cubed, that has a degree of 3, and then 5x squared, it's degree of 2, 2x, degree of 1, 7, degree of 0, from highest to lowest degree. And then our last vocabulary word is right here. The coefficient of the first term, and this is once it's in standard form, is called the leading coefficient. So, for example, here the leading coefficient is 4. It'd just be 1. It's like an imaginary 1 is there. Okay, so we're about to put all this together. And it's not as overwhelming as it seems. The directions here, it says, determine whether each expression is a polynomial. Okay, so that's when you've got to think about those things we talked about, like you can't have a variable in the denominator, or you can't have negative exponents. But what we can have now is we can have adding and subtracting. Because remember, a polynomial, it's either one monomial or the sum of several monomials. So now it says, if it is a polynomial, so if we say yes, we're going to find the degree, and then determine if it's a monomial, binomial, or trinomial. Okay, so A, is this a polynomial?
Yes.
Okay, we can say yes because there's no variables in the denominator, no negative exponents. So now I need to decide, is it a monomial, binomial, or trinomial? Binomial. I just did it in a different order. It's okay. Now let's find the degree. The degree is 1. Okay, y'all try to do the next 3.
What do I say? Oh. What is system in
If there's no adding and subtracting, then it's yes. Okay, for B. Yes? Oh, don't abbreviate this stuff. You can abbreviate degree, but you can't abbreviate monomial, binomial, and trinomial. Okay, the degree. 2. Good. This is no because of right here. Has d to the 4th power. Now, my question is, I said no, then I saw some people write trinomial. Is that correct?
No, because it's not a monomial. There is a
Yeah, so remember, if you go back to the top of your paper, we wrote that these two are types of polynomials. So if it's not a polynomial, then it can't be a type of a polynomial. That doesn't make sense. So if it's no, then you stop. It can't have a degree, and it can't be anything else.
I said no because it had division.
It can have division by a constant term. Like if it was just 5 on the denominator, then it would be. But if there's a variable in the denominator, then it's a no. Alyssa?
I thought the degree from 3 was 4.
No, remember, you do them individually, and then it's the greatest. Like, what's the degree of x squared? It's 2. And the degree of 2xy is 2. It's just the greatest. Don't add them together. Uh-huh. And then D. D is yes. And then what kind of polynomial is it?
Wait. How is it a...
And then the degree is 2. Try to give a question?
How is it a polynomial?
If you look at the top, it says a polynomial is a monomial or the sum of monomials. All right, go to the next page. That's not that bad. Okay, number 2. We are going to write these in standard form. So what does it mean if we're writing it in standard form? Gabby? Good. Okay, so first find the degree of each part. Okay, the degree of 9x squared is what?
2.
Good. The degree of 3x to the 6. And then 4x. Okay, so just remember, when you're rearranging these, if you're moving a term, the sign in front of it has to stay with it. Okay, so my first one is going to be the one with degree of 6. 3x to the 6th power. It's positive. And then I have positive 9x squared. And then negative 4x. I'll write minus 4x. Now, I'm okay with it if you abbreviate the leading coefficient. You can write LC. Once it's in standard form, it's the coefficient of the first term. So what's the coefficient of the very first term? 3. Okay, try to do B. Then it goes to the end. Once it's in standard form. Okay. Jack, what'd you get for this in standard form?
8xy squared plus 6xy plus 5y plus 12.
Good. I'll make sure you're checking your answers. Okay, so now the leading coefficient. Jackson?
8.
Good. Okay, any questions on this? I see it's not quite as bad as it seems. I know there's a lot of vocabulary, but keep it straight. Yeah, that's it. So this next part, you know how at the beginning of class when we were talking about the learning targets, I told you there's one you really already know how to do. This is I can add it and subtract polynomials. This is just putting together like terms. So think about these parentheses here. Do you really need them? No. What I like to do is I like to rewrite it without the parentheses and then solve it.
Why did I put the parentheses there?
Because the one's like the next problem. Or not the next one, but like 4. Okay, so when I'm putting these together, what do I put this 7y squared with? 5y squared, because they have the same variable and same exponent. So that's 12y squared. Okay, then I have 2y minus 4y. And then negative 3 plus 2 gives me negative 1. Okay, see if you can do B. Yeah, this is my answer because I can't add any more like terms. What? Oh, the leading coefficient? No, only if it tells you to in the directions. No. Yeah, that's what we're about to get to. Okay, so we're all trying B right here. 3B.
So you can't have a negative coefficient.
You can.
So what is this one?
Oh, something else. Don't worry about it. We're about to get there. Alyssa, what'd you get?
Negative 3x squared plus 1x minus 2.
Good.
Plus 1x.
Yeah.
Because look, it's negative 2x plus 3x. It's positive 1x. Let's say that. Okay, so number 4, this is what Christopher was just talking about. Christopher, tell everybody what you have to do here.
If there's a negative start parentheses, then out of negative 1, and then
We have to share this negative sign with everything in this parentheses. So on these, I do recommend rewriting it to help you not mess up. It's just easy to mess up with these signs.
so like why don't we just why can't you just subtract?
Well, you are subtracting it.
No.
So subtracting it and multiplying it by negative 1 are the same thing.
What? Why distribute it? Why
Hold
can't
on.
you just subtract the 2?
You can subtract it. It's still, the reason I like to go ahead and distribute it is because if you think of it like subtracting these, then you're going to end up with things like minus -7y. And that just messes some people up. So that's why I go ahead and just change these signs so I don't end up with minus negatives and plus negatives and things like that. Does that make sense? Watch how I do this stuff. Don't go ahead of me right now. The first like terms that I want to add together are these. Okay, the reason I'm doing those first is because they have the highest degree. You have to write your answers in standard form. Okay, so I'm going to write -1y to the 4th. And then what's the next highest degree after the y to the 4th? Y squared. So then I have plus 4y squared, and then I have just the y's. So plus 2y. So I would write a little note to yourself right here. You must write answers in standard form. Okay, now you can try B.
So like we have to write it
Yeah. Some people will just do them like in order, like they see them, and then rearrange them. That's fine too. I just like to do it as I'm combining like terms to take me a step. Bradley, what'd you get for this one?
I got 11 because I want +1 is the -2 and
Yes.
You just put in squared.
Yeah, that's fine. Good job. Okay, once you're finished with that one, go ahead and turn to the next page, and we have one word problem we're going to look at. Okay, so the big thing I want you to pay attention to as we read this is what the variables stand for, because there are, I think, 4 different variables in here. And just pay attention to what they are as we read. It says the total amount of toy sales T in billions of dollars consists of 2 groups: sales of video games V and sales of traditional toys R. In recent years, the sales of traditional toys and total sales could be represented by the following equations, where N is the number of years since 2000. Okay, so we have these 2 expressions, and they represent something. Okay, what does R represent?
The sales of traditional toys.
Traditional toy sales, yes. Okay, so then we have T.
Option for total amount of toy sales in billions of dollars.
Okay, so then we have V.
The sales of video games.
And then we have N.
The number of years since 2000.
Okay, so it says write an equation that represents the sales of video games. Anybody have an idea of what to do? Jeremiah?
What?
Okay, think about what these represent. The video game sales is equal to the total sales, everything, minus the traditional toys.
I don't understand.
Okay, so T is total sales, so this is everything. If I take away the traditional toys, then I have video games left. So, to figure out the video games, we're going to take T, this expression, minus R, minus this expression. Okay, so I'm going to have 0.45n cubed.
That means just
Mm-hmm. Oops, see, I didn't mean to put this parentheses here. Just pretend that's not there.
See, that's where I thought one thing like that. Oh, maybe this, you just say that on the
Like, can you write this on part B? Well, part B is a different question, so I'll let you. Then just label what you're doing part A. Okay, so now I need to distribute this subtraction sign to everything in the second set of parentheses. It is. $12. And I didn't give you any word problems today. You're welcome. Tomorrow you do have some. It's okay. That's not true. Okay, so try to finish this up and see if you can get to the correct answer. So I did a lot of it for you. All that's left to do is combine the like terms. Okay, so you should get this expression right here. Negative 0.01 n cubed plus 0.05 n squared plus 1.4 n plus 3.6. Okay, so now part B. It says use the equation to predict the amount of video game sales in the year 2012.
Is that all
Yes. Okay, did y'all hear what Lauren said? She said that means we need to plug in 12 because what does n represent? Years since 2000. So we're going to make n equal 12 and plug it in.
Oh, so we just use whatever's left over?
Yeah, we use what we just came up with in A and plug in 12.
I'll make...
So it
Before you do this though, one thing I want you to think about is do I do exponents first or do I multiply?
Wait, no, multiply.
No, that's when you're like solving an equation.
We talked about exponents.
Oh.
You're putting one. Wait, did we do parentheses?
Well,
I mean,
my parentheses are just there because of the multiplication. But you do exponents and then you multiply.
like where I have to put parentheses.
No.
Because the problem like 0.05 you multiply it by
Mhm.
you put in
Mhm. Does anybody know what the answer is yet? Jeremiah? Yes. Okay, yes. Make sure you notice that it's $10.32 billion. I'm going to give you a second to finish writing that down, but don't put this up yet. There's one more thing I want to show you. I need to go ahead and show you. I want to make sure we all know how to write this. Okay, does anybody know how many zeros 1 billion has? 9. Okay, so if I'm going to write 10.32 billion, this is what it's going to look like. Okay, because this is 10 billion and 0.32 of another billion.
Good afternoon, ladies and gentlemen. Listen up for